What's up, welders? This is part 2 of the basic build of the bar stool. Last week we fabricated the seat base and the 2 leg frames. In this video we'll be TIG welding the frames, and I'll be showing you how to minimise distortion and preventing the tube from sinking, but still giving it plenty of strength. You will see behind the hood while I'm welding, and I'll show you what to look for to get a nice weld. If you're worried that you don't want to take this project on because you think that you have to be really good to lay down a pretty weld to make it look good, don't worry, all of the welds get polished out to give it a nice professional clean look. So it's a good one to start on. If you're new to my channel, I make projects like this where I build and sell. And while I'm doing the video, I'll show you some time-saving tricks so you can do the same. So subscribe and click on the bell to stay up to date on my latest projects or my tool reviews. I have a free download of the materials required in the description below, or if you wish to purchase the drawings. A massive shout out to Joko Engineering YouTube channel. He drew my design in free CAD drawing software. You don't need expensive CAD programs to design projects like this. Just download the free software and away you go. Joko Engineering has excellent tutorials on free CAD. I highly recommend you checking him out to get you started. Stainless steel has a characteristic that's known as poor thermal conductivity. Now what this means is stainless steel doesn't have the ability to spread the heat from the weld zone further away, resulting in the concentration of the heat here, which distorts the metal. Now what does that mean for you as the welder? It means that you have to spend a little bit more time in thinking about how you're going to control distortion. In this example here, instead of welding the inside corner, there's too much leverage from the contracting weld, so it will pull everything in, resulting in outer square parts. What I like to do is weld the outside edge, and basically I'm just fusing the material together. I'm not adding any wire, because the more material you add to the weld pool, the more material that has to cool and contract, resulting in more distortion. It doesn't really need to be that strong. It does penetrate quite a lot, so it's still a good weld, but I really just want to lick this with a buffing wheel, and I don't have to dress it anymore. Once that's done, I'll start from this corner here, and then I'll weld out. And as I'm welding this way, all of the welding pool starts to contract even more. So it's pulling these outside edges further away. So when we finally come to weld this inside corner, the corner is so well locked in that the result of distortion is minimized as much as you can. I've got the machine set at 42 amps. You'll be able to go 5 amps higher depending on your machine or your experience. I have the gas set as low as I can get it. As nice as it is to have shiny welds or a light straw colour, that's not my concern. Saving argon is. All of these welds are going to be polished out, so as long as the welds aren't too grey or burnt, the corrosion resistance is going to be intact, so the weld integrity isn't going to be affected. Before I start welding, one of the most important pieces of advice I can give you, I got given, was never start welding until you're as comfortable as possible, and that is throughout the range of the weld. I don't know how many times, if you don't do it, you could start, and by the time you get to the end point of your weld, you're uncomfortable, you've made mistakes, you've moved, and your weld looks ugly. The material is 2 inch by 2 inch with a 1/16 wall thickness, or in metric it's 50.8 by 50.8 and 1.6 mil wall. The welds have been sped up 2.5 times to keep the videos a bit shorter, and I run out of things to say. I'm using a size 10 cup with a gas flow rate at 20 cubic feet an hour, or 9.5 litres a minute. The Pyrex cup is mainly to help you see better. I find a ceramic size 8 is a good balance for this type of work. I'm using 1/16 or 1.6mm 316 LSI filler wire. The SI means it has had silicone added. I prefer it because it helps the fluidity of the weld puddle. Stainless steel has to be encouraged where you want it to go, and the silicone helps. I will link to 7 common welding faults for stainless steel square tube in the top right hand corner now. The video will also be in the description below. Now that the seat frame is locked in place with all the welds on the 2 miters in the outside corner, we can go and do this inside corner weld. For this, I like to have the tungsten sticking out far enough so if the TIG torch is directly at 90 degrees to it, the tungsten still doesn't touch in the corner. You want it close because you want it to be a small weld, but not quite touching. When I go to do the welding, I'll be leaning it over between 15 to 20 degrees, and then that way that'll give enough room for the weld pool to build up and it still won't touch the tungsten. Before I start welding, I always have the filler wire ready in case there's a small hole or the two parent metals don't want to fuse together. That'll act as a bridge. I aim to keep the weld profile low to save time polishing. I'll have 2 videos on how to polish miter joints with the minimum equipment coming soon. Now that the 2 frames have been welded out, we've just got the seat base to be welded now. These don't need much welding at all. There's quite a lot of strength in it, and most of the strength will be coming from when it's actually welded to the 2 legs. Just like the stools, I would weld the outside edge here first, weld this one, and then on the diagonal weld that one, and then the same weld these ones here and here. And when we weld from the inside corner to the outside. Now this needs to be flush because the timber's getting put on top, so about 60-65 amps, and it'll penetrate heaps. You won't need to add much wire, so it'll be easy. To the astute viewers out there who have noticed that these have 3 extra holes on the top, that's Project Binky inspired. They're race lightning holes. They actually don't serve any purpose. You could say it was an accident, but whatever. Down here, I would be very careful because any welding on the outside, it'll pull outwards. And if you weld on the inside here, it's going to pull this angle in. And there's some timber that goes and covers this. So this is the strength that it'll provide the steel will be next to none. Just before we start welding, just remember to check the diagonal measurements. This will let you know if it's square or not. Luckily this one is. If it isn't, let's say this is the long side here, just give it a bit of a crack onto the concrete, not too much, and then that will shorten this distance here and then making this longer. So that's how you square up something with bugger all tools. For the footrest, I just sit the 25 by 50 off the radius of the RHS. It gives a nice clean look, and then that way you don't have to weld the outside and polish it. This will cut down 2 to 3 times the amount of work. When welding the footrest, you only want to have 1/8 or 3mm fillet weld. A larger weld will pull the feet of the legs together as the weld cools, contracting the metal. Once you have welded them and let them cool, you can place a straight edge across the top to check for any movement. If you do have a gap under the straight edge, the easiest way to fix this is to place a scissor jack between the 2 legs and gently jack it out to correct it. To protect the stainless, put some wood or thick cardboard as a barrier between the stainless and the jack. If you're finding this happening to most of the legs, I recommend cutting some wood to wedge in between the base of the legs to prevent it from shrinking.